In this video, we're going to look at expressions of the form ax squared plus bx plus c, where a is equal to 1. Such expressions are referred to as simple trinomials. Trinomials because there's 3 terms, and simple because the coefficient of x squared is 1. So if I look at this simple trinomial here, I have 1x squared plus 5x plus 6. Oftentimes this 1 isn't written out, but it's implied. Okay. The factored form of the simple trinomial is x plus 2 times x plus 3, and there's a couple of things that I want to point out. First of all, if you add the numbers 2 and 3 in the factored form together, you get a sum of 5. That sum appears over here as the coefficient of x. So whatever b value you see in the expression ax squared plus bx plus c, that's the sum of the two numbers that's going to appear in the factored form. Also, if you multiply the two numbers 2 and 3 together, you get a product of 6. That same product can be obtained by multiplying the outside numbers together. So by multiplying the values of a, c together, you get a product of the two numbers that are part of your factored form. If you can determine two numbers that satisfy the sum and the product based on the standard form of your quadratic expression, you can factor it very quickly. So let's take a look at the first example. We have x squared minus 2x minus 8. I know if I take 1 and multiply by negative 8, I get negative 8. So I'm looking for two numbers that have a product of negative 8. I'm also looking for two numbers that have a sum of negative 2. So two numbers that add up to negative 2. If you know your multiplication facts and you know addition and subtraction of integers well, you can come up with those numbers fairly quickly. The two numbers are going to be negative 4 and positive 2. Negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. These are the two numbers that will appear in the factored form. So my factored form is going to be x minus 4 times x plus 2. If you're not sure how to determine these quickly, you can use a systematic approach by writing out all the factors of 8 first. So factors of 8, starting with 1, would be 1 and 8. Okay, then you ask yourself, how many times does 2 go into 8? 2 goes into 8 4 times. So 2 and 4 are factors of 8. They multiply to give you 8. 3 doesn't go evenly into 8. And then the next number you're going to consider is 4. 4 goes into 8 twice, but we already have that combination of numbers 4 and 2. So there's only two combination of numbers that multiply to give you 8. 1 and 8 and 2 and 4. Now you have to consider the sign of the numbers in each combination. Since the product is negative, that means one of the numbers in the combination has to be negative as well. You make one of the numbers negative and add them together to see if you get a sum of positive 2. Negative 1 plus 8 gives me a sum of 7. That's not the right combination. If I switch the signs and make the 8 negative and the 1 positive, I get negative 7. Still not the right combination, giving me a sum of 2. So this is not the correct combination. The numbers involved must be 2 and 4. Now let's figure out the signs. If I make the 2 negative and add my numbers together, I get a sum of positive 2. But I need a sum of negative 2. So that means I have to make the 4 negative, and the 2 positive. And this would be the combination of numbers that satisfy the product of negative 8 and sum of negative 2. So if you're not sure what the two numbers are, right off the bat, you can kind of use a systematic approach to determine them. Okay, let's look at the next example. If I multiply 1 and 35 together, I get a product of 35. And then if I look at the coefficient of x, that will represent my sum, and it will be 12. So I'm looking for two numbers that multiply to give me 35 and at the same time add up to 12. The two numbers will be positive 7 and positive 5. The factored form will then be x plus 7 times x plus 5. In the next example, my product is going to be negative 72. my sum is going to be -1. That's implied here. So I'm looking for two numbers that multiply to give me 72, at the same time add up to -1. The two numbers are -9 and +8. The factored form is then going to be x minus 9 times x plus 8. And then in the last example, we have a product of 36, +36, and we have a sum of -13. The two numbers that satisfy that product and sum are going to be -9 and -4. The factored form will then be a minus 9 times a minus 4. When you're done factoring, you can always check to make sure you factored correctly by expanding back. So if I, for example, expand the last one here, I have a minus 9 times a minus 4. I'm going to take each term in the first bracket and multiply by each term in the second bracket. So a times a gives me a squared. A times -4 is -4a. -9 times a is -9a. And -9 times -4 is +36. Then when I combine my like terms in the middle, I get a squared minus 13a plus 36, which is my original expression. So this confirms that you factored correctly. Sorry. In this next example, make sure that whenever you're asked to factor, you factor fully. So that means you always have to look for common factors first. If you remove the common factor first, then you're working with smaller numbers, to which it's easier to find the right combination that satisfies the product and sum. So if I have 4x squared minus 8x minus 48, I notice that each one of these terms is divisible by 4. So I'm going to factor out the 4 and end up with x squared minus 2x minus 24. Inside the brackets, I'm left with a simple trinomial. The product of the simple trinomial is -24, and the sum is -2. The two numbers that satisfy that product and sum are -6 and +4. So now my final factored form would be 4, and then the expression x squared minus 2x minus 24 is going to be replaced with two factors. The first factor would be x minus 6, and the second factor would be x plus 4. In this very last example, I'm going to look for common factors again. Looking at the numbers 3, 21, and 24, I know the largest number that I can divide all of them by is 3. Then looking at the variable y, the one that has the lowest exponent is just y to the exponent 1, which is implied. So 3y is my greatest common factor. Dividing each of these three terms by 3y gives me y squared minus 7y minus 8. This leaves me with a simple trinomial. Three terms, coefficient of y squared, that's implied as 1. The product is going to be -8. The sum is going to be -7. So the two numbers that satisfy the product and sum are -8 and +1. These will appear in the factored form of the simple trinomial. I still have 3y at the front, followed by the bracket y minus 8 times y plus 1.